Ooh. Hmm. You know, 1 week from today, do you know what you guys will be doing? You will not be here because tomorrow or next week, next Wednesday marks the beginning of Thanksgiving break. That was crazy, huh? Thanksgiving. Well, good morning. Yeah, morning. I don't think I said that yet. Oh, you guys all matched today. Is it a thing? Okay, all right. Sweet action. All right. Yeah, this won't take long because you guys are super good at solving equations. So, what made last night's homework so easy, pleasant, was that the equations were all just like ready to go, right? So, you come to appreciate that. You come to appreciate that when someone gives you an equation that looks like this, you really kind of there comes a point where you appreciate that and say like, oh well, thank you, because that makes it really easy to graph. You go up 8, make a dot, down 3, right 4, down 3, right 4. Like, it takes very little time. So we start the mission today. This will probably take a couple of days because I'm going to give you the easy version today and the harder version of this tomorrow. Is we're going to start taking equations that don't look like this and we're going to make them look like this. So that's a pretty common strategy for graphing lines. Is not always is someone going to give you an equation and say graph this and give it to you in this lovely little format. So today we start practicing the art of making all equations look like this, because if I can take a funky looking equation and make it look like this, and this is my favorite method for graphing lines of all the methods that I teach you, then you think, well, I could just take them and make them look like this. So that's what today is all about. So we're converting standard form equations, and we're not going to talk too much about what standard is, but all the problems you get today are going to be in standard form, and you're going to convert them over into slope-intercept form. And I don't think it's difficult at all. It's probably a use paper and pencil assignment, I think. So we'll see how this goes. It's just not hard at all. I've had years in the past where this might be a difficult lesson, but again, you guys, with the amount of time and success with solving equations, you're not going to struggle with this at all. So here's an example. So you wouldn't want to try to graph this right now. Not until I teach you how to find intercepts. There's another method. It's kind of slick. It's not the best method in the world. It's a quick, sketchy kind of method, but barring that, you should be thinking, again, I wish this looked like yesterday so that I could make a graph of the line. And so it's really just like a literal equation, which you guys have already taken a quiz on. You know how literal equations just have more than one variable. And I could ask you to solve for anything. I mean, there's only two variables, X or Y, but I'm not going to ask you to solve for X because that's not what we're going for here. We're going for Y equals. That's the slope intercept. So this is our target. We want all answers today to look like this. Okay. So what do you suppose step one? I mean, I guess what I'm trying to say, and you probably already know this, is duh, I need you to solve for Y. So we're using our skills with literal equations today to convert junkier equations into graph-friendly equations. What would we do first to solve for Y? Yeah, let's get that 5x out of there for sure. And again, some of you show more work than others still. Um, I would say here's a gauge for you. If you're this person, then you're not ready to stop showing work yet, right? Like if that's you, if you don't see something glaringly wrong with that, then you probably should still be showing your work. So I'll go ahead and do this one officially, like the proper way. So like Morgan said, I want to subtract the 5x because I want it to go to the other side like this. So step one, you can't get y by itself in step one, but you can get the thing that holds the y by itself so that in a minute we can finish the job. So after I get rid of the 5x, I'm left with 3y equals. And since we look at that yellow box up there and say that's our target, how should we write the right-hand side? Say it again. There's no division here. Nope, it's just subtraction. That's not wrong. However, really look at the gold box and ask yourself again, how could I maybe write the right-hand side? Oh. You're not wrong if you say negative 12 minus 5x, and no math teacher can tell you that you are. Just telling you that I think, Tegan, you have a hand there. What do you think? Right. And that's, listen, if one person says the green thing and another person says the white thing, they're both correct. However, I'm going to choose the white one because I want my format to match the gold box. And you'll notice it's kind of subtle, but you don't really, doesn't stand out. But you notice that the X comes first. And I just feel with stuff like this, like we're going to be more successful if we do it uniformly, like every single time. So yeah, that's what I'm going for here is I want the right-hand side. I want this term, the one I'm circling, I want him to always go first. And since I subtracted, I'm going to call him negative 5x. And then, even though, it feels a little out of order, but it's okay. And then after that, I'm going to put the minus 12 like this. So that's step one, is get it prepped by getting the xy part off and over to the other side. Just move it. If it's negative, move it and make it positive. If it's positive, move it and make it negative. Simple pimple. All right, let's finish the job. We're not there yet. We don't match the gold box yet, but how could we get there? Divide everything by 3. And I want to tell you, I made reference to this many, many weeks ago, that there would come a day when I didn't want you to do this. There's no way you would remember that little miniature conversation. Today is that day. I don't want to apply the division like that to the right-hand side, because what I'm really trying to do here is pluck out the slope individually and pluck out the y-intercept individually. So rather than just applying one big glorious division sign to the right-hand side, what we're going to do is we're going to individually attack each of the terms with our division like this. And that enables us to see now all the parts and pieces here in a moment that we want to see. And this is going to get us to the gold box. This is our target, is to get it to look the way it's about to look. So if I cancel out the 3's, there you go, gone. I'm left with y equals what? Negative 5/3 of x minus 4. And now that is in slope-intercept form. And if I asked you to graph it, it would be easy. You'd go down 4, put a dot, and then go down 5, right 3, and make some dots. Easy peasy. That's the target objective for the day, is can we get really good at taking equations that look like this and make them look like this? All right, let's practice a few more. What do we do first? Right. And I'm going to try this time without showing my work, so you can come along for the ride. And if you don't like it, you can show your work. But I am doing what Morgan said. I am subtracting x, but when I show my work, air quotes work, it's going to say negative 4y equals what? Negative x and minus 24. So what's happening here is that this x is moving himself over, and he's like, I want to be tucked right there. That arrow is pointed very deliberately at the first spot right after the equal sign. And he says, when you move me, just change me from positive to negative, or negative to positive, whatever the case may be. Still good? Now what do we have to do? Divide everything by -4. And remember to use the divisions, like attack things individually, right? Think of it as like a three-headed monster of division there. Guys cancel out the -4s. What'd you get? Purple. Yeah, you got the hard part. I get a lot of questions about this part that's about to happen. Here it goes. Y equals. A lot of questions come up and people say, I don't know what the slope is going to be because there's a missing number. And yet again in math, invisible one to the rescue, right? And so if I put a green box around these numbers, I mean, those numbers are always going to create the slope, right? So I think to myself, basic math, that's a negative divided by a negative. So that's a positive. And I know that 1 divided by 4 is not 4, for God's sake. So I just leave it as a fraction of 1/4. And then I look at the y-intercept part, and that's a -24 being divided by another -4, giving me a +6. Still good? Okay. You got a question? Just stretching? All right. Thoughts? Yeah. Hey, Brendel, after you do that, what would the next line say if you add x to both sides? Nice job, bud. And now what do we have to do? Divide by the negative, right? And I think of dividing by a negative as just like a Harry Potter maneuver, like you just wave a wand and sinus changeus, like, you know. And so rather than make a real mathy thing out of it, when you divide by a negative, basically everyone undergoes a change. So -y becomes y, x becomes, and +8 becomes done. Can anyone go back to the very beginning and think of a quicker way that we could have solved this one? I've got no issues with the way Brendel did it. This is perfect and beautiful, but can anyone think of a little bit quicker route maybe that we could have gotten there? Huh? Let's go back in time and let's examine this guy, the guy with the red circle around him. What don't we like about him? Like, man, you're negative. Gosh, if only there was some way to make him positive, like right away. Is there? You could just do the switcherooski. And in a case like this, what I can do is take the red circle and the yellow circle and just have them cross paths like two ships passing in the night. Look at how if they just switch sides, and you can do this all in your head. So if the Y moves across, he becomes what we want, right? But then when he gets there, he's like, hey, 8, you're going to have to go ahead and get up off my side here. Because like, this is my side now. And when the 8 flies across, what does he become? Just like that, you're done. So if you move the red over to the right, you get Y. The -x just sits there and is like, you guys do your thing. I don't have to go anywhere. I'm fine. And so the -x stays. And then when the 8 hops over, he's like, done. Right? So if you see little opportunities like that, you're welcome to take them. Little shortcut method, right? I don't think there's going to be much trickeration. What's going to change after today's warm-up-y assignment is I'm going to start giving you problems that are harder, like negative 1/4 of y minus 2/3 of x equals -2. I mean, they're going to be worse than that too. They're going to be all over the place. They're going to be like 4 times x minus 1/2 plus y equals 3y. Stuff like this. So this is going to be more of tomorrow's lesson, and we can work through these if you want to right now. I was planning more to talk about the more like today's are all cut from the same cloth. Your x and y are going to be on one side, your number is going to be on the other side. That's called standard form. And but tomorrow I'm going to give you something else. It won't be today's Delta Math. Tomorrow will not be. And tomorrow will be a PDF or a worksheet where they're all like different looking, and you just have to kind of get creative and say, what could I do? Should I distribute? Should I kill fractions? And every problem is going to feel like a new challenge. But today, pretty straightforward. You guys good? You okay if I just leave stuff like this till tomorrow? Okay, today's assignment is number 17. It's on the old Delta Math. Again, I recommend paper and pencil. If you call me over and say, I need help with this, and you're not using paper and pencil, I am going to walk away. So just be advised. It's a good idea. Always a good idea. I'll leave this recording going. If anyone asks a question and I'm like, snap, I forgot to put that, then I'll just add it in. So I'll just pause this for now. Will you read it to me, bud? Plus 6y. Okay.
Equals 30.
Okay. So what should we do first? Okay, so what's my next line going to say?
6y equals -2x plus 30.
Nice. And I think I probably already know what you did, but let's work this out. What did you do next?
I divide 6.
So you divided here, here, and here. And I don't mean to try to like be a mind reader, but did you by chance put that? Oh, thank goodness. I assume you have plus 6 at the end? Okay, what did you put for your slope?
-2.
Like this?
Yeah.
Just like that?
And
yeah, as Rutley just learned, delta, I believe, is going to count you wrong if you don't reduce your slopes. So like, yeah, so if you have like a 2 and a 6, you got to reduce them to 1/3. I appreciate that. Rutley, you good?
Yeah.
Okay. What you got? I'm sorry, say, what'd you say? What'd you do first? No, that's a positive 6. Yeah. So what would our next line say? I want like a whole equation from left to right. So this has to stay here. The thing I'm pointing at with the arrow has to stay. So that's an important part. So the next line would say 4y. He's still going to sit there, right? We're not moving him. And then the right side is going to be what? Like this? I feel like we're missing something. Let me circle it for you. Yeah, that's kind of important, right? Okay. So if you move the 6x, he's still a 6x. He just changes signs. Good. Now what do we have to do? And we're going to divide here, here, and here. And usually 2 of those 3 are going to be really easy. So like this one that I'm crossing out is obviously easy because it's just y equals. And then this one back here that I'm crossing out is usually going to be pretty straightforward. It's just a division problem. And 8 divided by 4 is, of course, 2. So what we have to examine, you and I, is what's going on here in this yellow box, because that is going to be the slope, right? So let's examine that. First off, what's a negative divided by a positive? Okay, so we know it's going to be negative. And then what can you tell me about the fraction 6/4? Right? So if you divide them both by 2, what do you get? Does that make sense? Nice. New page. All right, what you got for me? What to do first? Oh, beautiful stuff so far. Then what'd you do? Okay. And so we get y equals. So what's your slope going to be? Negative, negative 2/3 of x minus 9. What you got?
Plus y equals 3.
Well, what'd you put?
Oh, you did do negative X.
Oh,
Did you forget to switch the sign of the x? Okay. Wow.
yeah, there we go. Yep, that was it.
Okay.
I got too ahead of myself.
Yeah, that's one of those that you probably don't need paper and pencil for, right? Yeah. What you got? Mm-hmm. What'd you do first? Stop saying that, okay? There you go. That's going to get you in trouble. So, so what is your next whole line, left to right, going to say? That's not the whole line. I need the whole equation. Now that is a whole line. Good job. Now what do we do? Good. Okay, so everything is in place. Now we just got to hope we don't mess up the answery part. So let's get to it. Right here where this yellow arrow is pointing is your slope. What's that going to be? Good. So we have 3/2 of x, right? And then right here where the green arrow is pointing is going to be the y-intercept. What's that going to be? There you go. Did you put -1? All righty. Can you read it to me, Cruz? Uh-huh. Yep. 60, 60. Okay. What did you do first? Now don't switch anybody, okay? What you want to think about is you just want to take this red box, don't move it. Leave it there. Okay? When I showed you that switch thing, the only time that I wouldn't even do that right now until you've mastered this, okay? So don't switch anybody right now. All I want you to do is get that red box by itself. Don't touch it, don't move it, okay? Leave it alone. It's like say brick, stay, I'll be back. So who has to get away from him? And how are we going to make that happen? Right. So if I subtract 12x right here, and I subtract 12x over here, what's going to happen now is these 12x's are going to cancel out. What is our next equation? The entire next line going to say, left to right? No, you're pulling a Cambry on me here. I need the entire equation from left to right, because here's the equal sign. So what is still over here on the left side? That's not a 20y. That's a negative 20y. We don't switch it or anything because we didn't move it. It just sits there with that box around it like, leave me here, don't touch me, okay? So the negative 20y is just hanging tight. Now, on the right-hand side, I have to put these two terms, basically just copy them down. But when we copy them, we want to put the x1 first and the non-x1 second. So what are we going to write? Then it's plus because it was a positive. Good job. So you understand so far? All we really accomplished there was we took this purple egg and we just relocated it to the other side and put it right after that equal sign. But when we put it there, we just remembered to switch it from positive to negative. Now what? Now we need to divide because now it's time to finish the job and say it's time to get y by itself. And how do we do that? Divide everything by what? Good. And so when we divide, Cruz, we want to show it here. We want to show it here. And we want to show it here. Okay, be really meticulous about that. Show that work everywhere. Now these negative 20s are going to cancel. And it's time to finish the job. So we now have y equals, we're done. Now, when you look at the slope is what's here in the purple box. Let's talk about that slope. Basic stuff. Is it going to be positive or negative? Right, because it's a negative dividing by another negative. And the fraction 12 over 20 has to be reduced. What can you divide those both by? You could. If you do that, you'll get 6 and 10. But then you'd look at that and go, nah, those can still both be divided again. So when you reduce, you got to think, I got to go all the way. So what now can you divide 6 and 10 both by? Huh? 6 and 10 are both even numbers. So by definition, they can both be divided by 2. So we already divided once by 2, but then we realized that we didn't go far enough. And then we're like, oh, I got to go again. So if I divide them both by 2 again, what do I get? And then you stick an X on the side of that, not on the low side, not on the high side, just perfectly off to the side. And then we have our first part done. Now we have to go to the red box. And the red box is going to be your y-intercept. Is it going to be positive or negative? Yeah, because that one's a positive 60 being divided by a negative 20. So we're definitely going to put negative here. Or minus, I should say. And now what is 60 divided by 20? Say again? Yeah, and I've already got the negative there, so I don't have to worry about that. I just 60 divided by 20 is all I'm worried about now. And that's 3. Got it?